Welcome back to another video. This is Dr. Tarcia Hubert, and in this video I am going to be talking about similar triangles, okay? But before we talk about similar triangles, we need to talk about some types of triangles. You can classify triangles in lots of different ways, but we're just going to talk about a few here where you can classify triangles based on their angles, and you can also classify triangles based on their sides. And so the very first triangle we have here is an obtuse triangle. An obtuse triangle is a triangle that has one obtuse angle. Recall that an obtuse angle is an angle that measures between 90 and 180 degrees. So if you look at this triangle here, here is your obtuse triangle right here. Your obtuse angle. This is the angle that's between 90 and 180. So because this triangle has one obtuse angle, it is considered an obtuse triangle. Next we have an acute triangle. An acute triangle is a triangle that has all acute angles. Well, recall that an acute angle is an angle between 0 and 90 degrees. And if you look at all three of these angles, they are less than 90 degrees. And so that would be considered an acute triangle. Then the third type of triangle we have here is a right triangle. And a right angle is an angle that measures 90 degrees. And so this would be the 90-degree angle here. And we use this half box to denote that it is a 90-degree angle. And because there's one right angle, then this will be considered a right triangle. So that's three ways you can classify triangles. Let's look at three more ways. So the last three were based on angles. These three will be based on sides, the lengths of the sides. So this first triangle is called a scalene triangle. It has no sides that are equal. So if you notice these little lines, this 1 mark, 2 mark, 3 marks, this lets you know that the sides are not equal. If the sides have the same number of marks, that means those sides are equal. If they all have different number of marks, that means they all have a different measure. So if they all have a different measure, that's called a scalene triangle. Now notice on this one, we have two sides with the same mark. They both have 1 mark. So that means those two sides are equal in length. This one has 2 marks. That means it has a different length. So you have a triangle with two sides equal. That's called an isosceles triangle. And then notice this one. They all have 1 mark. That means all of the sides are equal. And if all of the sides are equal, it's called an equilateral triangle. So that's three different ways that you can classify triangles based on their lengths of their sides. So scalene, isosceles, and equilateral triangles. So let's look at some examples. For this first example, classify the triangle as acute, right, or obtuse. I'm going to give you a second to make a guess. Hopefully you said that this is a right triangle. If you said right, then you are correct. Because of this 90-degree angle, which we normally use a half box to denote it, that's a right angle, which means it will be a right triangle. Classify this triangle as acute, right, or obtuse. I'll give you a second to take a guess. Hopefully you said obtuse. If you said obtuse, you are correct. This 130-degree angle is an obtuse angle, and because it has one obtuse angle, it makes it an obtuse triangle. Classify this triangle as acute, right, or obtuse. Hopefully you said that this is an acute triangle. If you say acute, you are correct. So all of these are less than 90 degrees. All of those angles are less than 90 degrees. That makes that an acute triangle. Now, it didn't ask us this, but notice all of the angles are the side. All of the sides are the same length. So that would also be an equilateral triangle, okay? Now you can have two triangles and they can be similar, but in order for them to be similar, they have to meet two conditions. Two triangles are considered similar if, first of all, their angles, their corresponding angles have the same measure. So if you look at these two triangles here, they're not exactly the same. You can tell this one on top is a little smaller than the one on bottom. But if you look at the angles, you see the little arc. So this 1 arc, 2 arc, 3 arcs is similar to the little tally marks that went through the sides earlier. It lets you know if those angles are equal. So here we know this has 1 arc, this has 1 arc. So angle A is equal to angle D. This has 2 arcs, this has 2 arcs. So angle B is equal to angle E. This has 3 arcs and this has 3 arcs. So angle C is equal to angle F. If the corresponding angles are equal, then that first condition holds, okay? The second condition has to be that the lengths of the sides have to be proportional. That means the ratio of the corresponding sides have to be equal. Okay, and I'll show you what that looks like in just a moment. Let's look at an example. So for this first example on similar triangles, this is actually example 4. Triangles ABC and triangle NMP are similar. So we want to find all unknown angles. So if you look, you see the corresponding sides. This one is one arc. This one is one arc. So angle A is equal to angle N. This one has 2 arcs, angle C, and angle P has 2 arcs. So angle P and C would be equal, and angle B and N would be equal. So I'm just going to write those out. Angle A is equal to angle N, and we know that angle A and N are 45 degrees. Angle C, I'm just going in the order of the arcs, is equal to angle P. And we know that angle P is 104 degrees. And then angle B is equal to angle M. And we don't know those yet, but we can find those because remember we know that the sums of the angles of a triangle equal 180. So if we look at this triangle, we see 2 of the angles. So if we say 104 plus 45 plus angle M, when we sum those up, we know they should equal 180. So if we add the 104 and the 45, we get 149. And if we want to solve for angle M, then we need to subtract the 149 from both sides. So we would get angle M is equal to, what is that, 31 degrees. So angle B and angle M will both be 31 degrees. So you can add them back together. 31 and 104 is 135, and 135 and 45 is 180. So that's just me going through the process of checking to make sure all of those angles add up to 180. So that's how you would find the measure of all the angles. Let's look at another one. Example 5, triangles ABC and DFE are similar. We want to find the lengths of all unknown sides, okay? So if we know they're similar, and we know their corresponding angles equal, but we also know that their corresponding sides are proportional. And so what we have to do is set up a proportionality. Now what's important is the order of the way the triangles are written. So this says ABC is similar to DFE. That means the length of AB, because AB comes first, is proportional to DF. So I'm just going to call that side X. And also the length of BC, which is the last two, is proportional to FE. BC and FE, I'm going to call that side Y. Okay? And then you could do the first and the last. AC corresponds to DE. If you see where I'm going here, the placement of how the letters are written in the triangle are important. Okay? So I want to set up a proportion. So that means this side 8 is to this side 16. So I'm going to set up a proportion. It says 8 to 16. And then I'm going to do the Y, which would correspond to the 32. So that's one proportion that I set up. Now there are multiple that I can set up, but this is just the first one. I know that the 8 corresponds to the 16 and the Y corresponds to the 32. So I set up a proportion and I solved it. Now there's 2 ways. Well, I haven't solved it. I'm about to solve it. There's 2 ways I could solve this. I can look at this and say, well, 16 times 2 is 32. So if I multiply the bottom by 2 to get to 32, then I'll do the same thing to the top. So that would tell me that Y is equal to 16. So that means the length of EF, the side EF, and we usually write the letters with a line on top, equals 16. Now, the other way you could do it is you could cross multiply. So you would do the 8 times 32 equals 16 times Y, and you could solve that out. 8 times 32 equals 16 times Y. Divide both sides by 16. So you do 8 times 32 divided by 16, and you will get that 16. Alrighty? Now, I need to also solve for the X. So I need to set up another proportion with the X in it. So I'm going to do the same 8 to 16 that I used in the first one, because the 8 corresponds to the 16. But now I'm going to do the X in the 24. Now for this one, I don't really know what, so I can't multiply 16 by like a whole number to get to 24. So for this one, I would actually do the cross multiplication. So 8 times 24 is equal to 16 times x. And then you will divide both sides by 16. So x is equal to 8 times 24 over 16. If you multiply that out, you will get 12. X is equal to 12. So the side DF would be 12. So we found the lengths of the missing side. So this x here is 12, this y here is 16. Alright, let's do one more of these. So this is a word problem. It says workers must measure the height of a building flagpole. They find that at the instance when the shadow of the building is 18 meters long, the shadow of the flagpole is 27 meters long. The building is 10 meters high. Find the length of the flagpole. Okay. So first of all, you have to understand how shadows are created. Shadows are created by the sun beaming down at an angle at an object, and then it causes the, that part of the building that's blocked from the sun and creates a shadow. All right, so since the flagpole and the fire station are right there at the same place, then the angle is shining at them at the sun is shining on them at the same degree. Since the sun is shining at the same degree, then all of the angles will be the same. So that gives us our first condition. All of the angles of a triangle or all of the corresponding angles of the triangles are equal. So we have the first condition met, and then the second condition would be that the sides are proportional, and they would be because of the sun shining down at the same, and hitting the buildings at the same angle degree. Sorry, y'all, I'm getting tongue tied. But because the angles are equal and the sides are proportional, these are similar triangles that are created. You can see the triangles here. So here's the first triangle that's created by the side of the building. The shadow, so this is the length of the shadow. And then this is just the hypotenuse that measures from the top of the building to the end of the shadow. So for the flagpole, one side is the length of the flagpole. The other side is the length of the shadow. And then this is just the hypotenuse that's formed from the top of the flagpole to the end of the shadow. So we have a set of similar triangles. And what we want to do is we want to create, so this is the side we're looking for. How tall is the flagpole? So we want to create basically a proportion. So x is to 10 because that's the vertical side, and since I use x here first, I have to use 27 here on top first. 27 is to 18. And for this one, I will cross multiply. 18 times x is equal to 27 times 10. Divide by 18. So x is equal to 270 over 18. 270 divided by 18 is 15. So that means the length of the flagpole would be 15 meters. And so that's how you use proportional triangles to solve this problem. If you have any questions whatsoever about any of the problems in this video, please don't hesitate to put them in the comments. Also, if you haven't already, go ahead and hit that subscribe button. If this video helped you to understand something better, then go ahead and hit the like button as well. Thank you all for watching, and I will see you in the next video.